session. Okay, so we are good to go. All right, so we are section. So first, let me ask if you guys have any question about the homework number 7. All right, so then so I guess we can continue with the section 2.7. This is section 2.7. So derivatives of logarithmic functions and exponential. So logarithmic functions and exponential functions. So Wednesday last week, I started with the derivative of exponential. So let me just remind you. So last week I tried to compute the derivative of exponential of x. So let me just remind you. So we had the following rule. So for exponential of x, so if you have f of x, so let's say f of x is equal to e to the x. So this is exponential function with base e. So again, e, that's a special number. It's approximately 2.71, right? So this is exponential of x. And so last week we said that the derivative f prime of x, the derivative is equal to the same function, is equal to e to the x. All right, so this is very something very specific to the exponential of x. So what we are saying here is that the function, the derivative of exponential is the same as the function f, right? So the derivative of f is equal to the function f, right? So this is very specific to the exponential, to the exponential, right? So we are saying. So what we are saying is that f of x is equal, f of x, the function f of x is equal to its derivative. Okay. So whenever you have e to the x, right, then the derivative is just the same function, e to the x. All right. Now, in general, if you have exponential with a base a, we said, if you have exponential f of x equal to a to the x, so this is the exponential function with base a. So with base a, right? Then f prime of x, then the derivative is equal to a to the x times natural log of a. Natural log of a, right? So when I say natural log of a, guys, I mean log in base e, right? So just to remind you, so the natural log. So when I say natural log of x, that's
Hi, Professor.
log. Yeah.
Excuse me, is that a to the x powered times,
Yes.
is that ln?
Yeah, this is ln. Yes, this is ln. This is natural log. Yeah, this is ln. Yes, this is ln. Yes, that's natural log. Yes, so that's a log in base e. Okay, so this is called natural log. Log in base e. All right. So we are saying if you have an exponential function with the base a, so a is not necessarily e, right? A could be any positive number. So then the derivative of a to the power x. So here again, here x is the exponent. X is not the base. X is the exponent, and we have some number. So a could be any positive number, right? So then the derivative of a to the x is a to the x times ln of a, natural log of a. So for example, examples. Well, let's say f of x So let's say f of x is equal to let's say 2 to the power x, right? So 2 to the power x, that's exponential function with base a equal to 2, right? So here our a is equal to 2, right? So this is base. So so the base is a equal to 2. So so what would be f prime of x? So then the derivative f prime of x. So we said the derivative would be, well, first you have a to the x, so it's the same thing. So we keep the a to the x, and we multiply by ln natural log of a. Okay, so our a is 2, right? A is equal to 2. So then f prime of x would be 2 to the x times ln, right? ln of a. A is 2, so ln of 2. Right? So this is derivative of 2 to the power x. You could have like a fraction, right? So for example, you could have, let's say you have example number 2. So let's say f of x is half to the power x. Okay, half to the power x. So here the base a would be equal to half, right? So here base a, the base a is equal to half, right? So then what would be the derivative? So then f prime of x, that would be equal to, so we said the formula, so the formula says the derivative would be, again, it's a to the x, we keep a to the x, so we have half to the x, so then in the derivative we're going to have half to the x times this natural log of a, right? So we keep the half to the x, so in the derivative we're going to have half to the power x times natural log of a, so natural log of half. Okay. So please, guys, feel free to interrupt me if you have any question, right? Another example, let's say you have f of x equal to 4 e to the x. Okay, 4 times e to the x. All right. So you want to compute derivative, right? You want to compute f prime of x. So what's f prime of x? Well, so this is, so here we have a multiplication, right? 4 times e to the x. It's a multiplication, right? So we have a constant. This is the constant 4, right? This is our constant times this function here, e to the x, right? This is a constant here, right? 4 times e to the x. So now, when we have a constant times a function, so what will be the derivative? So we have to keep, we have to keep the constant. So we keep the 4. So we keep this 4, right? And then we multiply by the derivative of the function. So here the function is e to the x, right? So derivative of e to the x, it's just, we said derivative of e to the x is e to the x, right? Remember here, guys? So if you have e to the x, the derivative is e to the x. So that would be 4 times derivative of e to the x is e to the x. All right, so you see here, guys, the function f is the same as the derivative. They are equal, right? F is equal to f prime. f is 4e to the x, f prime is also 4e to the x, right? Well, so another example, 1, 2, 3, 4. Now let's say we have f of x equal to x times e to the x. All right. So so when we take a look to this function f, this is x times e to the x. So here we have a multiplication, right? So we have a product. So this is a product x times e to the x, right? It's a product. So we have to apply the product rule. So we have to apply the product rule, right? Whenever you have a product, so if your function is a product, then you apply a product rule. So we apply the product rule.
Professor,
Yes.
why we didn't do that on the number 3?
We can do that also in number 3, and we're gonna have the same answer. So if you do that in number 3, that's a very good question actually. So we have a product, right? And you want to apply the product rule. So now, so if you apply the product rule, remember the product rule was, let me just remind you here of product rule. So if you have like f times g prime, then that would be f prime times g plus f g prime, right? So, so in number 3, so what would be the derivative of 4? 4 is a constant, right? So the derivative would be 0 times the second function, right? Times my g, the second function. So that's 0 times e to the x plus, now the function f, the first function, 4 times the derivative of the second function. So times g prime, and derivative of e to the x is e to the x. So it's 4 times e to the x, right? And because the derivative of a constant is 0, so this constant time, this 0 times e to the x cancel out, right? It's just 0, right? So so you see, I mean, when I say derivative of a constant times function would be the same constant times the derivative of a function, that's because it's a consequence of the product rule. Because, when you apply the product rule and your, let's say your function f, this function f here, it's a constant, this one is a constant, then this f prime would be 0, right? So if f prime is 0, then this whole thing here is 0, right? So then derivative is just if your function f is a constant, then the derivative would be the constant times the derivative of your function. So when we keep the constant, right? So if you have a constant times a function and you compute derivative, saying that you're going to keep the function and you multiply by the derivative of the function, right? So that's just a consequence of the product rule, right? So it's the same thing. Does it make sense to you, Mamadou?
Yes.
Okay,
Yes,
perfect.
thank you.
So it's like it's a shortcut. When you have a constant times another function, a constant times a function, it's just a shortcut when you keep the constant. Yeah. So here in example number 4, we apply the product rule again, if you want. Again, just let me remind you the product rule. So I'm gonna write here. So the product rule. So we have, let's say f. So f times g. The derivative, we said it's f prime g plus f g prime. Okay. So this x here is like f in the rule, and e to the x is like g, right? So f times g. Now the derivative, so f prime of x right? So first, derivative of the first function. So the first function is x, right? This is my first function, which is x. So derivative of the first function, derivative of x is 1, right? Because we applied the power rule. Remember, if you have x to the power n, derivative, that will be n, x to the n minus 1. So if your n is 1, so you will bring down 1 and you will subtract 1 from the power of x. So that will be x to the power 0, which is 1. So derivative of x is 1 times the second function. The second function is, of course, is e to the x. So 1 times e to the x plus, and then the first function, x, times the derivative of the second function, which is e to the x. And derivative of e to the x is just e to the x, right? So that's x times e to the x. So the answer here, so f prime of x, so f prime of x, that would be e to the x. 1 times e to the x, of course, is e to the x, plus x times e to the x. All right, so this is the final answer. Okay. So again, guys, here again, when you have a derivative to compute, first you need to know which derivative rule you're gonna apply, right? So like here you have x times e to the x. That's a product, so you have to apply a product rule. So in our next example, we're gonna have a quotient. We're gonna have a fraction. So then, so next example 5. Let's say f of x is e to the x minus 1 over x squared plus 1. Right? That's my function f. And of course, I want to compute the derivative. I want to compute f prime of x. Right? So this function here, f, it's a fraction, right? This is a quotient. So if it's a quotient, then this is we have a division, right? So this is quotient, so we have to apply the quotient rule. Right? So we have to apply the quotient rule because it's a fraction, right? So what's the quotient rule? Well, so let me just remind you here, quotient rule. So if you have like f over g, like you have a quotient, right? F over g, and you want to compute the derivative. So then quotient rule says that that's actually equal to f prime g minus, okay, this is minus, it's not plus, minus f g prime over g squared. All right. So like, again, like, so here in my example, f, so this f would be the top. So the f would be the top. So f of x would be the top. That's e to the x minus 1. And the denominator g, that's the bottom here. That's the x squared. That's the x squared plus 1. Right? So that's my f, that's my g, and this is my quotient rule. Right? So now in the quotient rule, you have to compute f prime times g minus f times g prime over g squared. So right? So, well, let's compute the derivative then. So then the derivative of our function, so f prime of x. So first, the quotient rule says it's f prime. So my f, this is my f, that's the e to the x minus 1, right? So what's the derivative of f prime? What's the derivative of this e to the x minus 1? So we have subtraction. So if you have a subtraction, then there is no special rule. There is no special rule you need to apply. So all you have to do is take the derivative of the e to the x. Derivative of e to the x is e to the x. What is this minus? So minus, and then derivative of a constant by itself. So if you have a constant by itself, derivative would be 0. right? So it's e to the x minus 0, right? Now, what about the derivative of the g? So g prime. First, we have x squared. It's an addition here, right? So we're going to take the derivative of the first function here plus the derivative of the second function, right? So derivative of x squared is, it's just bring down the 2 and decrease the power by 1. So it's 2x plus, and then you have plus 1. Again, that's just a constant by itself, and derivative of a constant by itself is just 0. So it's 2x plus 0. Right? So, okay, so I got my f prime, I have my g prime, so I can apply now my quotient rule. So quotient rule said, we said it's f prime first. So that's the e to the x. So here's my e to the x times the g. The g, that's the bottom, that's the denominator. That's the x squared plus 1. So here's my x squared plus 1. And there's a minus. Okay, so in the quotient rule, we have a minus in the top. So this is minus f. F, again, that's the top, right? That's the e to the x minus 1 times g prime, derivative of g. So this is g, and this is g prime. So g prime is just 2x, right? G prime is just 2x over, so the denominator is going to be always the square of the g, the square of the bottom. So the square of the x squared plus 1. So then square, right? Any question, guys? So that will be the derivative of my function here, right? Okay. Yeah, one more example, and then I'm going to give you an exercise. So one more example. So this is example 5. So let's move to the example number 6.
Oh, I got a question.
Yeah, please.
We don't need to simplify it, or
Yeah, I mean, you can try to simplify here, but yes, you can try to simplify, but the thing here, there will be no simplification. Even if you distribute the answer, even if you distribute, then there will be no simplification.
okay.
But yes, you're right. You should try to simplify your answer. That's correct, right? But here in this particular case, there will be no simplification. All right, because I mean, you can see it from, you see here, e to the x multiplied by x squared, right?
Yeah.
And then you have e to the x times 1. And here it's e to the x times x. It's not e to the x times x squared. Here it's e to the x times x. And then here there's this 1 times 2x. So even if you distribute everything, then there will be no simplification. All right. Okay. But you're right. Good point. I mean, in general, you need to try to simplify the answer. Okay, so a last example, 6. All right, so then let's take the following function. Let's call this function here h of x. And let's say h of x is e to the x squared minus x. All right. So here, guys, you have to understand this function h. So the exponent here is the x squared minus x. So what I'm saying here is, so that's e to the power x squared minus x. So this is our exponent, right? Okay, so this is e to the power x squared minus x. So e to the power x squared minus x, right? So, all right. So now the question is, well, for example, let's do an example. So for example, what would be h of 1? you want to compute, let's say, you want to evaluate h of 1, right? So you have to plug 1 in the function h, right? So e 1 squared minus 1.
1, right?
Yeah, so what you do is first you compute the power, right? This power here. So we have to compute this power. So that's e to the power, so 1 squared is 1, so it's 1 minus 1. So that's e to the power 0, right? 1 minus 1 is 0. So that's e to the power 0. And what would be e to the power 0?
1.
1. Yeah, absolutely. So non-zero number to the power 0, it's 1. Absolutely. So h of 1 is 1. Anyway, so my point is this x squared minus x, that's my power, right? Now the question is, of course, so what's the, yes?
Why you try to find h of 1?
No, just trying to give an example. I'm just saying, trying to explain that this x squared minus x is it's the power of the exponential. So the whole x squared minus x is the exponent here. I'm just trying to explain that the x squared minus x is the exponent.
Okay.
Right. This is just an example here. Just trying to explain this function h. Right. Okay. Now the main question, the main problem is what's h prime of x? Okay. Well, so we do know, the derivative of e to the x, right? We know that the derivative of e to the x is e to the x. But this is not e to the x. This is e to the x squared minus x, right? So the derivative of this e to the x squared minus x, it's not just e to the x squared minus x, right? So now the question is, so which rule we're gonna apply to compute the derivative of this?
Quotient
Which one?
rule.
Do you see any quotient here? Do you see any fraction?
We can bring the exponential of minus x to the denominator, having exponential x squared over exponential x.
Actually, that's true. That's true. Yes, that's true. You can write e to the x squared over e to the x. That's what you are saying, right?
Yes.
Okay. But now you're gonna have still a problem. So you know the derivative of this, but what about the derivative of the e to the x squared? So Elias, yes, absolutely, Elias, you're correct. That's actually the chain rule. So this e to the power x squared minus x. So this is like saying the power x squared minus x of e. So here, this is like of the form f of g, right? This is so that we're gonna apply the chain rule. So even for this, you see this e to the x squared. So this is like saying power x squared of e, right? So what I'm saying, guys, is that, let me just erase this. So what I'm saying is, so when I say e to the power x squared minus x, so this is like saying the power. So the way we read this is the following. That's the power x squared minus x of e. So as Elias said, so this is actually of the form f of g of x. So what will be what will be f and what will be g? So when you say the power x squared minus x of e, so this is like f as I said, this is like f of the function g. So your function f, so this is, let me erase this here. So this is power f. So this is e to the, so this is e to the, so e to the power x squared minus x, right? So then your f, so let's say your f of x is e to the x, and g of x is x squared minus x, right? So what will be f of g, so f of g, so this is f of g of x. So what we do, guys, of course, is let me put this x g. So this is my f of x. So what you're saying is this is f. So let's say f of x is e to the x, and here's my g. I'm gonna write g on the other side. So x squared minus x. So then f of g of x, so you substitute this x here, this x by g of x, right? So then that will be e to the power g of x. And instead of x, we substitute x by g of x. So that's e to the power g of x. And so that's e to the power x squared minus x. And that's exactly my function h. All right. So then we have to apply the chain rule. So then we have to apply the chain rule. So what will be the chain rule? So h prime, the derivative, that will be, so then h prime of x, that will be g prime of x times f prime of g of x. All right, so then what will be g prime of x? So you see here, guys, in this chain rule, we need g prime and we need f prime of g, right? So first, g prime of x. So we said g of x is x squared minus x. So then g prime derivative. So this is just a subtraction, right? So first, I need the derivative of x squared. That's just 2x. There's this minus, so it's minus. And then derivative of x, we said derivative of x is 1, right? We apply the power rule, so it's 1. Now, next, we need f prime of g of x, not f prime, just f prime of x. Again, this is composition. It's not, this is not multiplication here. It's f prime of g, right? This is, it's not multiplication here. This is, so this thing here, this is a composition of f prime with g, right? So it's not multiplication. It's not f prime times g. It's f prime of g. So anyway, so what's this f prime of g? Well, first f of x we said is e to the x, right? Then f prime of x, derivative of e to the x, we said it's just e to the x. Now the question is, what's f prime of g of x? So we have to substitute x by g of x. So this x here, here's my x. So I have to substitute x with g of x. So now we're gonna have e to the g of x. All right. So that's So then f prime of g of x, that will be e to the, and g is x squared minus x. So that's e to the x squared minus x. So I got my f prime of g of x. This is here g prime of x. So now the final answer, h prime of x. It's g prime of x. So that's the 2x minus 1 times the f prime of g of x, and that's e to the x squared minus x. Right? And that will be a fine answer. So yeah, so this is this is the chain rule. So whenever I have like e to some function, I mean, if it was just e to the x, you see guys here, if it was, if you have like just e to the x, then yes, derivative of e to the x, it's just e to the x, same. The derivative is the same as the function f. But this is not e to the x. This is e to the x squared minus x. So this is e to some function, right? And actually, we can deduce a rule whenever we have a function which is like which is of the form e to the to some function f. So actually, we can deduce. So we have here corollary. Right. So what I'm saying, guys, is that if you have some function which is of the form e to some function, so let's say h of x is equal to e to the to some function, let's say g of x, so e to the power g of x. So this is e to the power g of x. Right?
G prime times exponential to g to the x.
Yes. So then h prime, yes, very good, Mamadou, yes. So then h prime of x. So your f here, so this e to the g of x, you can write like a composition of f with g, where f is just the exponential of x. So then h prime, so I claim that h prime would be just g prime of x times e times the same function, so times e to the g of x. Right? Again, this is just so this is just a corollary. We can deduce this from the chain rule, right? This is because again, this is e to the power g of x. This is composition of the function exponential with the function g, right? So I mean, in the future, guys, instead of using the chain rule, you can just use this rule here. But again, it's up to you. You can also use the chain rule instead of this. I mean, this is just a. I mean, this is just a corollary consequence of the. This is just a consequence of the chain rule, right? This is a consequence. This is a consequence of the chain rule. All right. So one more example, guys, and then I'm going to give you an exercise. All right. So one more example, just to just to use this consequence of the chain rule. So this is example number. Let's say example number 7, probably. Yes, 7. All right. So example number 7. Example number 7. So let's say you have h of x equal to e to the power cosine of x, right? So here again, the power is cosine of x. Right? This is e to the power cosine of x, right? So let's say you want to compute h prime. Okay. So if you want to use this rule here, this one, so if you have a function h of the form e to the power to the power g of x, so then my g of x would be this cosine of x, right? This would be my g of x, right? Then what we are saying is the rule is the following. Then the derivative h prime would be g prime times e to the g of x, right? So what would be g prime? G of x is cosine of x. So then g prime of x, derivative of cosine of x, we know it's a minus sign, right? So it's minus sine of x. So this is here, this is g prime of x times e to the g of x times e to the cosine of x. Like, so this is e to the g, right? This is e to the g of x, right? So that's the answer. So the answer, minus sine of x times e to the, so h prime of x, it's minus sine of x times e to the cosine of x. Any question, guys? Okay, so then, so here's an exercise about the derivative of exponential functions. So exercise. So probably I'm gonna move to the next page. Okay, so let me move to the next page. Okay, so exercise.
Professor, can you wait
Yes.
1 second?
Oh yeah, sure. I can come back, sure. Oops. Okay. All right. Okay, now I am in trouble. Okay. So I have to go all the way down, I guess. Is this okay?
Yes.
Okay. Yeah, so guys, after the exponential, of course, so we're gonna have an exercise about exponential functions. And then, yeah, after the exponential, of course, we're gonna move to the logarithmic functions, right? The derivative of log of x, etc., right? And we'll see, I mean, derivative of log is gonna be a consequence of, because it's gonna be a consequence of derivative of exponential, right? Because, you know, by definition, the log is the inverse of exponential of x, right? So you will see how we compute the derivative of log using the derivative of exponential.
Thank you, Professor.
Sure. So here's an exercise, guys. So please compute or try to compute the derivative. So please compute h prime of x. So 1, 2, 3, and 4. So let's say first f of x is exponential of x times cosine of x, right? Let's call the function h instead of f. This is, let's say, h of x, sorry. So it's h of x. So then h of x, then let's say you have 1 plus x squared over e to the x minus x, right? 3 h of x is equal to e of, so this is e of square root of x, right? So here the power, the exponent is the square root of x, right? And finally, h of x is equal to x times e to the x squared. All right. Okay, guys. So now you know the derivative of exponential. You know derivative of the trig functions. You know how to compute derivative of quotient, of product. Okay, so we have all the ingredients to compute the derivative of these functions h of x. All right. So let's say you have let's say 5-10 minutes, 10 minutes to compute the derivative of h of x. Please let me know if you need any help or you have any question. Just let me know. All right. Um, Yes, by the way, guys, I on Thursday, I guess I will post the homework number 8, but also the extra credit. All right, so so you should expect the extra credit this Thursday on Blackboard. So this is section 2.7, guys. So once we are done with this section, I'm gonna come back to the section 2.6, right? All right. Is there any question about this exercise, guys? Any remark? All right. So no questions so far, Emma? Okay, very good. So probably I can go over number one. All right, so number one, that's so it's h of x equal to e to the x times cosine of x. All right, so this function h, it's a product, right? It's e to the x times cosine of x. So it's a product. It's a product of two functions, e to the x with the cosine of x. So because it's a product, so this is a product, so we have to apply the product rule. So then apply product rule. Product rule. So what does it say, the product rule? Let's say this is my f of x, this is my g of x, this is f of x. So if h of x is equal to f of x times g of x, then h prime of x, that will be f prime of x times g of x minus f times g prime. Plus, this is plus. So we are talking about the product rule plus f times g prime of x, right? Plus g prime of x. All right, so first I need, so here's f prime times g plus f times g prime. So we need f prime, we need g prime. So my f of x, is e to the x, right? So my f of x is e to the x. Derivative of e to the x, by definition, it's e to the x.
Right.
Yes. And then g of x is cosine. Then g prime, we know derivative of cosine of x, it's minus sine of x. Okay, that's the derivative of cosine of x. Okay, now I can apply my product rule. So then h prime, that will be f prime. So that will be the f prime, that's the e to the x, times g, times the cosine of x, plus, this is a plus here, so plus f, which is again e to the x, times g prime, right, times f times g prime. So my f here, this is my f times g prime, which is minus sine of x. Right. So that's my h prime. You can factor out. I mean, e to the x is a common factor. You see here e to the x. It's a common factor, so you can factor out e to the x if you want. So then h prime of x would be e to the x times, so cosine of x. This cosine of x, there's this minus, so here's minus, and then sine of x, minus sine of x, right? So I just factor out the e to the x. Here's my e
Okay,
to the
see,
x.
I did everything except factor in the e to
No,
the
it's fine. If you don't factor, it's fine. It's still fine. Yeah, it's correct. Both answers are correct. Right.
Okay, thank you.
I'm just I'm just saying, if you want, I mean, if you prefer, you can also you can also factor your h prime. So yes, so h prime. So this would be the answer, or this one here. Okay. All right. Any question about number 1? So that's a product rule. So first you need to know which rule you're gonna apply. It's a product, you apply product rule, and then yeah, and then you get your derivative. All right, so what about number 2? Well, number 2, it's, so you can
Quotient
see
rule.
quotient rule. Absolutely, thank you, Juanita. Yes, so number 2 is gonna be a quotient rule. So let me write down number 2. So it's h of x. It's 1 plus x squared over e to the x minus x. So 1 plus x squared over e to the x minus x. So this is like f over g. So it's a quotient, so we're gonna apply quotient rule. So then h prime, that will be f prime of x times g of x minus f of x times g prime over z squared of x. Right? So this is my quotient rule. All right, so now all I have to do is to compute f prime, g prime, and then to plug everything in the formula, right? So so what's f prime? Well, f of x. Oh yeah, sure, I can zoom out. Yeah, okay, sure.
Is it 2x?
Okay, let me check again. Oh yeah, it's 2x. Yeah, the f prime is the 2x. Yes, absolutely. So f of x is 1 plus x squared. So as you said, f prime of x is 2x. It's 0 plus 2x. So it's 2x. Now, what about g prime? So g is the bottom, is the denominator. So that's ex minus x. So then g prime. So here, guys, e to the x minus x, it's a subtraction, right? So it's not a product, it's not quotient. All you have to do is to compute the derivative of each term. So derivative first of e to the x. Just said derivative of e to the x is e to the x. There's minus, and derivative of x is 1, right? Apply power rule. This is x to the power 1. So apply power rule, so it's 1. Okay, so then, and so then this is, so then your h prime of x. So first, so we have f prime. So here's my f prime, it's 2x. So here's my 2x times, and then times g, right? This is g here. So where's my g? Well, here's my g. It's the e to the x minus x. G is the denominator. So it's times e to the x minus x. And then there's this minus. So here I'm going to keep the minus. F, right? There's this f here. So here's my f. It's the 1 plus x squared minus 1 plus x squared times, and then there's the g prime. And then, so there is this g prime here. And g prime, we said it's the e to the x minus 1. So it's times e to the x minus 1 over the whole thing over the square of g, right? So it's g squared. So it's e to the x minus x squared. All right. You can try to simplify actually this h prime. I mean, this is correct. This is a correct answer, but then you can also try to simplify, because there is actually probably 1 or 2 simplifications. Because if you distribute, so this 2x times e to the x, so that's 2x e to the x. There's this minus, so here's minus, 2x times x, so that's 2x squared, right? And then there's this minus, so I'm going to keep the minus. 1 times e to the x, it's e to the x. 1 times -1, that's -1. There's a minus, so that's +1. Distribute the sign, right? And then there's this x squared times e to the x, minus x squared e to the x. And finally, x squared times -1, that's minus x squared. And there's a minus outside, so that's plus x squared. So here it's plus x squared, and the whole thing over e to the x minus x squared. So here, I mean, there's probably just one simplification. You see, this is this minus 2x squared plus x squared. So that'll be minus x squared, right? So there's only one simplification. So again, guys, I mean, you have to try to simplify your derivative. So like here, we're gonna have 2x e to the x minus 2x squared plus x squared. That will be minus x squared. And then there is minus e to the x plus 1 minus x squared e to the x over this e to the x minus x squared. Right? So that's the answer, right? So you can also try to, if you prefer, or if you want, you can also factor out the e to the x in the top. I mean, but I mean, this answer is okay, right? This would be probably the final answer. Right. So that's for the quotient rule. So that's for number 2. Number 3. Number 3 is e to the square root of x. So this is for number 2. So this is, we said this is our final answer. So this is our final answer. Okay. So number 3, it's h of x equal to e to the power square root of x, right? So the power here is the square root of x. Right, so first question is, of course, which rule I'm gonna apply to compute the derivative here of h? Is there a product? Do you see a product here, guys? Well, there's no multiplication, right? So it's not a product. Do you see a quotient or fraction? There's no quotient or fraction, so it's not quotient rule. So if it's not the product rule, not the chain rule, then of course the remaining rule would be the chain rule, right? So this is of the form. Remember we had this rule with. So let me just remind you the rule we had. So we said if you have h of x equal to e to the power g of x. So the power is some function g, right? Then we said h prime, then h prime is g prime e to the same power, g of x. We keep the same power, right? So what will be g of x in this example? Well, it's e to the g. So my g of x is the square root of x, right? That's my g of x. That's my g of x. So now I want to compute the derivative. So I need g prime, right? So what's g prime? So g of x, we said it's the square root of x, which is, by the way, x to the power half, right? That's the square root of x. So what will be then the derivative? Derivative of x to the power half. So then g prime. So remember the power rule, guys? We have x with some power. So this power is half. You bring down the power and you subtract 1. So I'm going to bring down the power half in front of x. Subtract 1 from half. That's negative half, right? So 1/2 minus 1, that's negative half. So that's my g prime of x. Right, so I got my, I got my g prime of x. So now I can answer the question. So find the answer. So h prime, it's the g prime. So here's my g prime. So it's g prime, which is half x to the negative half times e to the g. So e times e to the power, the same function, g, which is square root of x. So e to the square root of x, or x, e to the x power half. Right? Is there any question about this one, guys? So Ibrahima, do you see what I meant by e to the g? So here you keep the same function, right? This here should be e to the g of x, right? E to the g of x, the same function.
Yeah, I got the same thing.
Okay. Okay. Okay, so that's for number 3. Number 4. So where's number 4? So number 4, it's x times e to the x squared. So number 4, it's h of x. So we said it's x times, sorry, we said it's number 4, x times e to the x squared. So number 4, so it's x times e to the x squared, right? So first thing, guys, do we see a product here? Yes, there's a product, right? This is multiplication. There's a multiplication here. That's a product. So we're going to apply the product rule. So we're going to apply the product rule. Product rule. So let's say this is f of x, and this x here is f of x, and this e to the x squared is my g of x. So then product rule, derivative, so h prime would be f prime times g of x plus f times g prime. Right? That's the product rule. All right, so we need, so to apply this product rule, I need to compute f prime. I know g, right? I know g. G is the e to the x squared. So I need to compute f prime, and then there's f again. So f, I know f is x. Then I need to compute g prime. So let's compute f prime and g prime. So first, f of x is the first function, it's x. So then f prime of x, right? So then that will be equal to, so this is 1. You bring down the 1, we subtract 1 from the power, that's x to the power 0, so that will be 1. Okay. Now what about g prime of x? So g of x, it's the e to the x squared, right? So what will be the derivative, g prime? So e to the x squared, it's not just e to the x. If it was just e to the x, then yes, the derivative would be e to the x. But this is e to the x squared, right? The power here, it's x squared. So we have to apply our rule. Remember the rule we had in number 3? So this x squared here, that will be like our, g of x. So this is like e to the g of x, right? G prime, so it's a derivative, it's going to be the derivative of this function here, the power, derivative of x squared, it's 2x times, and then we keep the exponential to the same power. So exponential to the same power, right? Again, this is like my example with, the example with the e to the square root of x, right? This e here to the square root of x. In the number 4, we have e to the x squared. So e to the square root of x, we said here in the front, we have the derivative of square root of x times e to the same power. So same thing here. This is e to the x squared. So derivative of x squared here in the front times e to the same power. So now I got everything. I can compute my h prime. So then h prime of x, it's f prime. That's 1. So it's 1 times g. So g is the e to the x squared plus, so plus f. My f is x, right? So my f is x times g prime of x. So g prime of x is this 2x e to the x squared, right? So then final answer would be, so let's multiply everything here, h prime of x. So that'll be e to the x squared plus 2x squared e to the x squared. And so this would be a fine answer, but you can also, if you want, you can factor out e to the x squared because it's a count factor. So then h prime of x would be e to the x squared times 1, because here it's like 1 left here, plus, and then there's this 2x squared. All right. So that would be a fine answer. As I said, you can factor out. It's up to you. If you don't want to factor out, you don't have to factor out. Okay. All right, guys. Any question about this number 4? All right. So no. Okay. Perfect then. So let's take a break. So let's take a break of 5 minutes, guys, and then after the break, and then after the break, we will continue with
Colgando.
after the break, guys, we'll continue with the logarithmic functions. All right. So let's take a break 5 minutes, and then we'll continue with the derivative of log. Right. Okay, so break 5 minutes. All right, guys. So let's continue with the derivative. So after the exponential, now we have log. So now, derivative of logarithmic functions. All right, so let me first remind you definition of log, a logarithmic function. So log is the inverse function of exponential, right? So by definition, so when you say, let's say y is equal to log in base a of x, so this is equivalent to a to the power y equal to x. All right, so this is equivalent to a to the power y equal to x. All right, so for example, so this is just an example. For example, let's say you want to compute log in base a of 1, all right? So this is, let's say, y, all right? So what will be log in base a of 1? What will be log of 1? Well, that's by definition, this is equivalent to a to the power y equal to x, right? Equal to your x. Here's your x here. So x is 1. So a to the power y equal to 1. So then what will be y? Well, that y would be 0, right? Because a to the power 0 is equal to 1. So y is equal to 0. So what I'm saying is, conclusion is that log in base a of 1 is equal to 0. Right? Actually, log of 1 in any base is 0, right? So anyway, so I'm saying, so this is the definition of the logarithmic function as the inverse function of the exponential. So this is, of course, this function here. This is the exponential in base a, right? Anyway, so that's the definition of log in base a of x. All right, so now, so just to remind you, natural log. So natural log is when the base a is equal to the number e, right? So this is just to remind you. So when you say natural log of x, ln of x, that's the log in base e of x, right? So another thing, guys. So when you say log of x, or log in base a or base e of x, it's not log times x. It's log of x, right? It's like saying cosine of x, right? Cosine of the angle x. It's not cosine times x. It's cosine of the angle x, right? So you cannot separate the cosine from the x, right? You need the variable x. So the same for log. When you say log of x, right? So it's not log times x, it's log of the number x, right? So you cannot separate the log from x. Or when you say, for example, of course, when you say sine of x or etc., right? Anyway, okay, so now the goal is, of course, so this is just to remind you definition of log. So for now, we want to compute, of course, the derivative, right? So now the goal is So now we want to compute so the goal is to compute the derivative of log of the function y of x equal to log in base a of x. All right. So, well, so we're gonna use the definition of log. So we said y of x. So y is log in base a of x. So we said this is equivalent to, you know, equivalent to a to the power y equal to x, right? Now, I want to compute the derivative of this a to the power y equal to x, right? So this is, so now let's compute the derivative of a to the power y equal to x. Remember, guys, so this y is supposed to be a function of x. So this y here, this is a function of x. This is our, so when I say y, I mean y of x, I mean log in base a of x, right? So this y here is a function of x. Function of x. Right, so the y, again, the y, here's my y, is equal to the log in base a of x. Now, what's the derivative of this a to the power y? So we have a to the power y of x, and this is y of x equal to x. Okay, so I want to compute the derivative. And here's the derivative, both sides. So what will be the derivative of the both sides? Now, so the left side. So how do we compute the derivative of this left side? So this is, so the left side, this is like exponential. This is, you know, this is exponential on base a of the function y of x, right? So this is, so to compute derivative of this a to the power y of x, we need to apply the chain rule, right? This is, so chain rule, right? So it's like, so this is like f of g of x, where f of x is a to the power x, and g of x is y of x, right? Because so f of g of x, that would be a to the power y of x, right? So if you apply the chain rule to this a to the power y of x, right? So then the derivative would be, well, g prime. So g is y of x. So g prime, that would be y prime, right? So y prime of x, that's my g prime, all right? And okay, g prime, let me write it down here. So g prime of x, that will be y prime of x. Now, what about f prime of x? Well, f of x is a to the x, right? So then f prime of x, that will be, so we said derivative of a to the x, exponential on base a of x, we said the derivative is a to the x times ln of a, right? That's the derivative of a to the x. But in the chain rule, we need f prime of g of x. So that will be a, f prime of g of x. So we need to substitute x by g of x, right? So that's a of g of x ln of a, right? So, and my g of x is y of x, right? So here we're gonna have a to the power y of x times ln of a equal to, and on the right side we have x. So what's the derivative of x with respect to x? It's 1. Okay. So what I'm saying, guys, is that y prime. So y prime of x, y prime a to the power y times ln of a is equal to 1. Right. So then my derivative. Again, I want to compute the derivative of y. Right. Y is, remember y? Y was y of x. Y of x, that was my log in base a of x, and I want to compute the derivative of log of x in base a, right? So y prime, that's the derivative I'm looking for. So I'm gonna solve for y prime. Okay, so then y prime is gonna be equal to, and so I'm gonna divide here by a to the y times natural log of a. Here, same thing, a to the y natural log of a. So then y prime is equal to, 1 over, right, a to the y times natural log of a. But the thing is, a to the y, remember the definition here, we said a to the y is equal to x. So you see here, a to the y is equal to x. So the y prime here, that would be, so y prime would be, y prime of x would be 1 over x times ln of a. Okay. So anyway, so the conclusion, guys, so all you have to memorize is that is the following rule. So if you have log, so the rule is the following rule. So let's say your function f of x is equal to log in base a of x, okay? Then f prime of x is equal to 1 over x times ln of a, natural log of a. Now, if a is equal to e, so in the special case, in the particular case, so when a is equal to e, so when a is equal to e, then so f of x would be log in base e of x, so that's natural log of x. Okay, and f prime of x is going to be equal to 1 over, so natural log of e, by definition, natural log of e is equal to 1, right? So then f prime of x would be 1 over x. So what I'm saying, guys, is that if you have natural log of x, the derivative is 1 over x. And in general, if you have log in base a of x, the derivative would be 1 over x times natural log of a. Okay, so then the rule you need to remember is this one here. If you have natural log of x, so if you have natural log of x, then derivative is 1 over x. And in general, this is the derivative when you have log in base a. Right? So any question about the rule here, guys? So all I'm saying is derivative of natural log of x is 1 over x. So compared to the exponential, remember, derivative of exponential of x is exponential of x, right? So for the exponential, the function is the same as the derivative, right? But here for natural log, natural log of x, the derivative is kind of different, right? It's actually 1 over x. So it's a completely different function, right? All right, so that's the rule we're gonna apply in the coming examples. So examples. So example. So first example. So let's say h of x is equal to log in base 4 of x. Okay, and you want to compute h prime. So this is log in base a, so a would be 4, right? So base a here, base a is equal to 4, right? So we need to apply this rule here. If my function is log in base a of x, then the derivative, so what would be the derivative then? It's just 1 over x, 1 over x times natural log of a, right? Natural log of a. So a is 4, so that's natural log of 4, right? So what I'm saying, guys, is so derivative of log of x in base 4, that will be 1 over x times natural log of 4. Okay, so because my base a is equal to 4. Right, another example. So this is example number 1. Example number 2. So let's say h of x is equal to 3 times natural log of x. Okay. So what would be h prime of x? So this is 3 times natural log of x. Well, here it's a product. Of course, you can apply a product rule, right? But as I said, if you have a product, but one of the function is a constant, right? This in this product, the first function is a constant, right? So when you compute the derivative, all you have to do, you don't have to apply the product rule. Well, instead of the product rule, all you have to do is just keep the constant, right? Keep the constant. So the constant is 3, so I'm going to keep the 3 times, and then the derivative of your function here, this again, the natural log of x, right? So the derivative of natural log of x, well, we said if my function is natural log of x, then the derivative is just 1 over x, right? So this is 3 times 1 over x. Okay. So h prime of x, so the answer would be h prime of x. So this 3 here, we can write like 3 over 1. So it's actually 3 over x. So that would be the answer. So h prime is 3 over x. Any question, guys? Okay. Now let's say you have, so this is a constant times natural log. Now let's say you have x. Okay, thank you, Juanita. So now let's say you have h of x equal to x squared times natural log of x. Okay, so now we have a product, but the first function is not a constant, right? First function is x squared. So this is a product. Okay, and the first function is not a constant, right? It's x squared. So then we have to apply the product rule. So we have to apply the product rule. Right, so remember product rule. So let's say this is f, this is g, right? Then the product rule says the derivative of f times g, that will be f prime times g plus f times g prime. Right, so then h prime of x, so then h prime of x First, we need derivative of f prime. F is x squared, right? Here's my f, it's x squared. So what's the derivative of x squared? Power rule, right? Bring down the power in front of x, and then you subtract 1 from the power of x. So it's 2 times x. That's my f prime times g. My g is the second function, right? It's the natural log of x. So here's my natural log of x. And then there's a plus. So here's a plus. F, the first function, which is x squared, times the g prime. So what's g prime? What's g? G is natural log of x, right? So what's the derivative of natural log of x? Well, we just learned that the derivative of natural log of x is 1 over x. So g prime is 1 over x, right? So in other words, h prime of x, it's actually 2x natural log of x plus x squared over x. Well, here you can simplify, right? X squared over x. I mean, x is power 1, so you subtract 1 from 2. So then it's, so h prime of x is 2x natural log of x plus x. All right, so that would be a fine answer. You can also, if you want, you can factor out x, right? If you want. So this, in other words, h prime of x is x times 2 ln of x plus 1, right? If you factor out x, it's up to you. If you don't want to factor out x, it's fine. So yeah, so that's an example where we have to apply the product rule with the natural log of x. Okay, if there's no question, then I can move to the next example. So this is product rule. Next example is going to be about the quotient rule. So let's say h of x is equal to 1 plus natural log of x over x plus 2. All right. So this is a quotient, right? This is a quotient. So we're going to apply. Oops. So this is, I was saying, sorry. So I was saying this is a quotient. So we're going to apply the quotient rule. All right. So the top would be my f of x, and the denominator, that will be my g of x. All right. And so the quotient rule, the derivative of f over g, so then h prime, h prime of x, so this is my quotient rule, so that will be f prime times g minus f g prime over g squared. Okay. All right, so then let's compute h prime. Well, so h prime of x. First, we need f prime. So f is 1 plus, f is the numerator, right? That's the top. So derivative of 1 plus natural log of x. So first, it's not a product, it's not a fraction, it's just a addition, right? So first, derivative of 1. 1 is a constant, derivative of constant is 0, right? So that's 0 plus, and then derivative of natural log of x, it's 1 over x. So it's 0 plus 1 over x. So that's my f prime, right? This is my f prime. This is f prime. Now times, next, times g. G is the denominator, is the x plus 2. So times x plus 2. So this is my g. This is my g, right? And then there's minus. So here's minus f. F is the top, is the 1 plus natural log of x. So 1 plus natural log of x. and then times g prime, right? Times the g prime here. So what's g prime? Well, here is g. It's x plus 2. X plus 2, it's not, it's just addition, right? So then derivative of x is 1 plus derivative of 2 is 0. So it's just times 1 here. Times 1 over the g square, the x plus 2 square. Okay. So, okay, so let's try to simplify this h prime of x. So let's see what happens. So h prime of x, I mean, this is 0. 1 over x times x. See here, guys, 1 over x times x. So x cancel out. X over x is 1. There's a plus. And then 2 times, this 2 here times 1 over x. So 2 over x. And then there's minus. Right, this minus here, minus 1 times 1, it's 1, minus 1. And natural log of x times 1, it's just natural log of x. So it's minus natural log of x over the x plus 2 squared. Now you can see, guys, there's 1 minus 1 cancel out. 1 minus 1 cancel out. So then the answer h prime of x. So then h prime of x would be 2 over x minus natural log of x over the x plus 2 square. Right, so that would be a fine answer. Any question, guys? All right, so then one more example. So we applied the product rule, we applied the quotient rule. So now in the last example, we're going to apply the chain rule. So example number 5. Example number 5. So let's say h of x is natural log of x squared. Okay. So this is natural log of x squared, right? So it's not natural log times x squared. It's natural log of x squared, right? So it's not natural log of x. If it was natural log of x, then yes, the derivative would be just 1 over x, right? So, but there, here in this problem, it's natural log of x squared, right? So we said it's not natural log times x squared, it's natural log. So this is natural log of x squared. So that reminds you the chain rule, because this is of the form f of g, or f of x of g of x. So then what will be f of x? F of x, that will be a natural log of x. And of course, g of x, that will be the x squared, right? So what I'm saying is, so this h of x, I can write like a composition of 2 functions. So f of x is, we said it's going to be natural log of x. And g of x is the x squared. And so when you do f of g, so when you substitute x by g, this x here by g of x, so here's g of x, so that'll be, so this is going to be natural log of g of x. And g of x, we said it's just x squared, right? So it's natural log of x squared. And that's exactly my h, right? My h is natural log of x squared. So that's my h of x. So my h is the composition of 2 functions, f and g, f of g of x, where f is natural log of x and g of x is x squared, right? So yeah, so now the question, of course, is what will be the derivative? So what's h prime? So then h prime, so then that will be the chain rule. So this is the chain rule. So it's g prime of x, f prime of g of x. All right. So first we need g prime, right? We need g prime. So g of x is x squared. So g prime of x is just, you bring down the power and you subtract 1 from the power. So it's 2x. Okay, now next we need f prime of g, not f prime times g. So f prime of g. So f prime, so first, what's f prime? Well, f of x we said is, f of x, it's here, it's natural log of x, right? So then f prime, we said derivative of natural log of x, it's 1 over x. So then f prime of x is 1 over x, right? Derivative of log, natural log of a natural log is 1 over x. Now, we have to substitute again x by g of x, right? So this x here, this x by g of x, right? So then, so we need f prime of g of x. So that'll be 1 over g of x. So that'll be 1 over, so g of x is x squared, right? G of x is x squared, so 1 over x squared. Okay. So I got my g prime of x and I got my f prime of g of x. And so then, so final answer, so h prime, we said it's g prime, it's the 2x times f prime of g of x times the 1 over x squared. So that would be equal to 2x over x squared. So x over x squared, subtract the powers, this is power 1. So it's 2 minus 1, so it's just 1. So it's 2 over x. So then h prime, so then the answer h prime is equal to 2 over x. Okay. So actually, well, so we can, like, you know, like what we did for exponential, we can deduce the following rule. So whenever you have natural log of some function, so so this is a consequence. So corollary, this is a consequence of the chain rule. A consequence of the chain rule. So if you have h of x, consequence of the chain rule, right? So whenever you have, if your h of x is equal to natural log of some function g, natural log of g of x, then h prime, that will be using the chain rule, that will be g prime of x over g of x. Okay, so again, this is a consequence of the chain rule. So the you see here natural log of g of x. So this is like f of g, right? My f would be the natural log of x, and the g of x is g of x, right? So we can apply the chain rule, and so by the chain rule we get that the derivative h prime would be g prime over g, right? So for example, if we try again to do the example we had, so example, so let's say h of x is natural log of x squared, right? So let's try to apply this this rule here. So my g, you see, so my h is natural log of g of x. So your g of x is this x squared, right? So then we said h prime. So then h prime would be G prime over G. So then H prime of X, it's G prime. G is X squared. So G prime is bring down the power, subtract 1 from the power. So it's 2X over G of X, right? Over the G of X here, right? So over X squared. And that's exactly the 2 over X. Okay. Anyway, so what I'm saying, guys, is that whenever we have natural log of some function G, then derivative is G prime over G. Okay. So again, this is G prime of X, and this is my G of X. Any question, guys? All right, so here's an exercise with a log. So exercise. So keep in mind. So what you have to memorize or to keep in mind, the derivative of a natural log of X is 1 over X. Right? Derivative of natural log of X is 1 over X, and derivative of natural log of G of X, it's G prime of X over G of X, right? So let me just write down here for you. So what you have to really keep in mind is that if you have f of x equal to natural log of x, then the derivative f prime of x is 1 over x. F prime of x is 1 over x. And if you have f of x equal to natural log of some function g, then f prime, the derivative, is g prime of x over g of x. All right, so that's what you really need to keep in mind, all right? So here's an exercise. So exercise.
Professor, I have a question.
Yes, yeah, please.
So you would only perform the chain rule, the consequence of the chain rule only if you have a natural log over g of x?
Yes.
Okay.
Yeah, so yeah. So if you have natural log of g of x, then yeah.
Okay.
Then yeah, you're right.
Okay, thank you.
So exercise. So please find or compute h prime of x. So compute h prime of x. So let's say first h of x is equal to let's see, yes, is equal to x cubed times natural log of x. Okay. Number two, h of x is equal to x minus x squared over natural log of x minus 1. All right. Number three here. And number 4. So number 3, h of x is natural log of cosine of x. Right? And number 4, h of x is equal to sine of natural log of x. Okay. All right, guys. You have let's say let's see. Yeah, let's say you have 10 minutes, 15 minutes to think, to find, to compute this the h prime of x. Of course, I am here to answer if you have any question. So this is, of course, Please, guys, don't forget your homework number 7. It's due on Wednesday. Okay, guys. I mean, we have like 5 minutes. That will be probably just enough to solve problem number 1. And so probably next time, next we are not done yet with this section 2.7 with this derivative of log and exponential. And so I will continue. I will solve number 2, 3, and 4 next time, I guess, and we'll continue the section 2.7 next time. But let me just try to solve, number 1. Right. Okay. So just for number 1. Okay, so number 1, so here's my h of x cubed times natural log of x. So as I said, this is because it's a multiplication, so it's a product of f of x. So this would be my f of x, and g of x. G of x would be the ln of x, right? Now, what's the product rule? So what does it say, the product rule? So product rule, the derivative, h prime of x. So h prime of x, that will be f prime of x times g of x plus f of x times g prime of x. Okay, so so let's see. My f is x cubed, my g is natural log of x. So let's compute this h prime. So f prime of x, f of x is x cubed, right? F prime of x, x cubed, so that's the power of x. So you bring down the power times x to the power, and you subtract 1 from the power of x, right? So bring down the power, that's 3, times x, and you subtract 1 from the power, so that's square. So derivative f prime of x is this 3x squared, right? Times the g of x, okay, so times the second function, that's the natural log of x. All right, so this is my g of x. And then there's a plus, so here's my plus f, same function, which is x cubed times g prime. Well, now the question is, what's g prime? G is ln of x, and you just learned that the derivative of the ln of x is 1 over x. All right, that's the g prime of x. Now, here we can simplify because, so we're going to have h prime of x, 3x squared times natural log of x, plus, so this is x cubed times 1 over x, so it's like x cubed over x, right? And again, guys, you think of x like x to the power 1, right? So if you take the difference between the powers, 3 minus 1, that would be 2. So that would be x squared, right? So that's so your h prime of x, 3x squared, natural log of x plus x squared, right? X squared, x cubed over x, it's x squared. You can you can factor out x squared because x squared, it's a common factor. Right, so if you factor out x squared, so then h prime of x, my x squared here, times, you factor out this, as I said, you factor out this x squared, right? So then it's x squared times the natural log of x, there's a plus, so plus, and if you pull out x squared here, then you are left with 1, right? So because this is like x squared times 1, so it's plus 1. All right, so this is then my h prime of x. So yes, so any question, guys, about this h prime of x? So that's a product rule, right? So we use the fact that derivative of natural log of x is 1 over x. All right, so I see there's a question in the chat. Oh, no question. Yes, Ibrahima, you are correct. Your answer is correct. Yes, for number 4. Absolutely, yes. All right, guys. I guess I'm gonna stop here for today, right? And I will continue with number 2, 3, and 4 next time, and we'll finish, I guess, section 2.7 on Wednesday. So we do have a class on Wednesday. I will see you on next Wednesday. I will see you on Wednesday. So yeah. So thank you, everyone, and I will see you, I guess, on Wednesday. Good
Have a
night,
good
everyone.
night,
Thank you.
Professor.
Thank
See
you,
you
everyone.
Wednesday.
See you Wednesday. Take care. Thank you, everyone. Thank you, Ibrahima.
Thank you, Professor.
Thank you, Whitney. Appreciate. See you Wednesday.